Okay, so they're giving me things here. They're telling me the reciprocal of 35. So I'll write that down. So 1 over 35. I want to make it look like the other one. And they say it's approximately equal to 0.02857. So what I did was I decided to write down, something to do with section 110. I write down this sequence. I write it over here. Here I know that A1, I write this over here, A1 in that sequence is 0.02857. And then what do? I start computing the differences, just like we did in 110, no different. Yes, I cheated a little bit. I used the computer to do that. You get tired, all right? And we do the difference 2. Wow, that's convenient. And you get this over here. So then the question is what do they want to know? Well, they want to know the reciprocal. I'll write this over here, 36.28. So that's going to be A something. Let's take a look at it. So this is the reciprocal of 35. This is going to be A1. This is going to be A2. So what do I want? I want A 2.28, right? Now again, it's important you understand that this is A2. So I want A 2.28. So I just use the formula. Let me cut to the chase. We'll go to the next page. And I want to point out what we're looking for, A 2.8. I write the formula down, A1. Again, I'm not trying to memorize. That's right over here. That's a given. Then when I get 2.28 minus 1 times the D1, what's the D1? Well, it's minus 0.3079. I got that. Then 2.28 minus 1, 2.28 minus 2 over 2 factorial. And then I got to get that next D, which is going to be D2. It's going to be 4 zeros and a 4. Now again, I don't know why I'm writing this down because it's 0. My suspicion, if I did the computation correctly, and yes, I used a computer to do it. I did not do that hand arithmetic, like watching paint dry. But again, it's remarkable. In 1904, they were doing the computations by hand. And it's remarkable. By the way, they employed people to do it, but nonetheless, remarkable. You should get that number over there. Again, someone says, do you really need to do that method to get there? I don't think I would do that. I really don't. But it's remarkable how accurate this is. And what's the actual number going to be if I did my calculator? This is the number over here. And by the way, you can write down something like this. But again, we're looking for an approximation of it. And, we did pretty good. If you look at that number, this number here, it's really a good approximation. Calculator can do better. Now, if you're going to study mathematics further and you're going to applied mathematics, developing algorithms to approximate things is really important, all right? Now, you think about your calculators, how good they're at it. Probably, again, I don't know much about calculators, but probably that's well known across all calculator designers what the best algorithms are to approximate. And again, I don't know much about that field, but it's a rich field. Now, certainly in other areas, like in data analysis, again, a lot of things are approximations, and we're looking to approximate. Okay, my name is Ron Bannon. If you need to reach out to me, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. I think the biggest challenging with these problems is figure out what the subscript is and the arithmetic. The arithmetic is not the easiest thing in the world to do. Thank you.